question 1, nice and easy start. Just make sure that you're adding them up downwards and adding them up to the right, and you should get those 3 numbers as shown. So question below, keyword here is independent. So for independence, you just need to show that this AND works how you think it should work. So you check the probability of O, you check the probability of U. If you multiply those 2 things together, it should give you the answer as the probability of those 2 together, as from the table. So probability of O and U, so you've got 2922 from the top middle of the table. That's being older than 24 and being an undergraduate, 2,922 of those out of the total. So I've put that as a decimal, 0.1286. And then I've checked the probability of being older than 24. So that's 8,576 out of the 22,000. And the probability of being an undergraduate, so that's over here. And then I've multiplied those 2 together manually. So I've done that down here. So 0.37, 0.69, multiplied them together, 0.2611. And then we've just said, look, they're not equal. So the 0.12 and the 0.26, they're not equal to each other. And if they were independent, they would be. So our ideas of probability haven't worked there, so they're not independent events. Okay, so on to this guy. So 3 people picked at random. They've all got to be born on the same day of the week. So you can either say, okay, look, they're all born on Monday, all born on Tuesday, all born on Wednesday. There's 7 different possibilities here. And then just say, right, so it's 1/7 for probability of Monday, 1/7, 1/7, so 3 lots of that. Multiply it by 7 because there's 7 different options. And that will give you the answer. Or you can say, look, it doesn't matter what the first day is. It doesn't matter whether it's Monday, Tuesday, Wednesday, it doesn't matter. And then once you've picked that, so let's say it's a Wednesday, then it's 1 out of 7 that the second person will be a Wednesday, and then it's also 1 out of 7 that the next person will be a Wednesday. So either of those 2 options, you can either cancel the 7th out because there's 7 different options, or just say the first day doesn't matter. Either way, you get 1 out of 49. Okay, so this one, loads of words. You can do it with algebra, with the G and the G plus B, because it's the girls and it's girls plus boys here. I don't think that's the best way, although that is shown in the answers. I don't think that's great. I would do this trial and error. So I'd say, look, if you've got 3/5 and you add 4 girls and 4 boys, you're making the 3 into a 7 and the 5 into a 13. So you're adding 8 at the bottom and 4 at the top. Does that equal the 4/7 that they've told you? So 7 out of 13 is not 4/7. So that doesn't work. Okay, instead of saying there's 3 girls out of 5 people, we could say there's 6 girls out of 10 people, because that's still 3/5. And then if you add the 4 and the 8 on, does that make 4/7? No. Okay, we'll try a different kind of multiple of this then. So 9 out of 15, that's still 3/5. So you'd have 9 girls and you'd have 15 total. Okay, if you add 4 girls on, you'd have 13. If you add 8 total, 23. Does that make 4/7? No, that doesn't simplify to 4/7. But this one does. So that's the answer. So 12 girls, 20 in total, making 8 boys. So yeah, 12 girls, 8 boys. And just put it there at the bottom.